Dear viewers, to this another paper of 2019 November Science Paper 2. So for today we'll be looking at the Harber process, okay? The process of manufacturing ammonia. So this is one of the method that is taken mostly in industries when they are manufacturing ammonia. All right, so let's study the diagram, okay? So this question was taken from 2019, okay? It was taken from 2019 November. So the question states nitrogen is used to manufacture ammonia, okay, as shown in the diagram. So we have nitrogen, these are sources, okay? So if you look at the sources of nitrogen, nitrogen is taken from the air because nitrogen exists as 78% of the atmospheric air. Okay, and then we have X. Okay, so X is hydrogen from hydrocarbons. Okay, and then we have the temperature of Y temperature, and then we have the catalyst, and then we have ATM of pressure, and then there is an output of ammonia, okay, as a product. Now, name the process shown above. So this process, we call it the Harber process, okay? So this is the Harber process. So in the Harber process, there is a combination of nitrogen and hydrogen in the presence of 400 degrees Celsius of temperature, and then the catalyst of ion catalyst, okay, and then also the atmospheric pressure of 200 to 250, and then the output is ammonia. Okay, so we can be asked a question like B, state the substance represented by letter X. So what is the substance letter X? So letter X is hydrogen, hydrogen from the hydrocarbons. That's what letter X is, okay? So X is hydrogen, okay? And then we have this other question, okay? C, write the condition, okay, represented by Y and Z needed for the process. So we have Y and Z. So Y is temperature, and then this one is pressure. So we can state Y is 400 degrees Celsius of temperature, okay, and Z is a pressure of 200 to 250 atm or atmospheric pressure, okay. And then we have this other question, okay. C or D. D1, name the catalyst used. So what is the catalyst used? So we use ion catalyst. So ion catalyst is used for the process, okay? So there we can say ion catalyst, which is Fe. This is the symbol for ion, okay? And then we can also look at this other one. 2, write the main ore from which the catalyst named in D1 is extracted. So where is the catalyst extracted? So the catalyst is extracted from hematite. So hematite is the ore. Okay, so when they say the ore, they mean the mineral or the actual material where iron is extracted from. So hematite, the other name is iron 3 oxide. Okay, so there are also other actual ores where iron can be extracted, like magnetite. Magnetite is one of it. Okay, and then also we have iron carbonate, it's one of it. So those are some of the sources of iron, okay, or the ores of iron. Okay, so we can just name one. Okay, and then the other question, E, construct the balanced chemical equation for the reaction shown in the diagram. Include the state symbols. Okay, so the balanced chemical equation which we can write, we have to include the ammonia. So there is nitrogen. So nitrogen comes from the air. So it is taken as a diatomic element, is N2. Okay, plus hydrogen. So hydrogen is 3H2. Okay, so this comes from the hydrocarbons. And then in the output, we have ammonia. So ammonia is given out as a compound, okay? So the reaction is reversible, okay? So these products can be changed into reactants. Okay, so if you're looking at the equation, here we have two nitrogen there, okay, 6 hydrogens. If we multiply 2 times 3, we get 6. So the equation is balanced, okay? And then the last question, so in the last question we have state one use of ammonia. So ammonia is used for various purposes, but the common use which we have is ammonia is used in the manufacture of chemical fertilizers. Okay, apart from manufacturing of chemical fertilizers, ammonia is also used as a coolant in refrigerators. Okay, so those are some of the uses of ammonia. Okay, so thank you for watching the video. Please subscribe to the channel. Okay, share the video and stay tuned for more. Thank you.